There's a planet that's older than the universe itself. But here's what doesn't make sense. The universe is 13.8 billion years old. This planet is 12.7 billion years old. That means it formed when the cosmos was barely 1 billion years old. 1 billion years. That's before most galaxies existed, before stars had time to explode and scatter the heavy elements that planets are made of, before the cosmic kitchen had any ingredients. It's like finding a finished painting in an artist's studio before the paint was invented. The canvas is there, the colors are perfect, but the materials to create it didn't exist yet. The timeline is broken. Scientists call this planet Methuselah, named after the oldest man in the Bible, and for 20 years, nobody has been able to explain how it exists. The ingredients weren't there, the recipe wasn't ready, the universe wasn't old enough. But there it is, 12,400 light-years away, floating in an ancient star cluster, waiting for someone to solve the puzzle. Make sure you're subscribed, because what I'm about to show you challenges everything we thought we knew about how planets are born. Here's what astronomers actually found. To understand why Methuselah is impossible, you first need to understand how planets are supposed to form. The universe builds planets like a chef builds a meal. You need ingredients first, then you need time to cook. The ingredients for planets are heavy elements: iron, silicon, magnesium, oxygen. These are the building blocks that form rocky cores and solid foundations. But heavy elements don't just appear out of nowhere. They're forged inside stars. Massive stars burn through their fuel over millions of years. Then they explode as supernovae. When they explode, they scatter those heavy elements across space like seeds thrown into cosmic soil. New stars form from that enriched material. Dust disks swirl around them, and slowly, over millions of years, planets come together piece by piece. This process takes time. Generations of stars must live and die before enough ingredients accumulate. Scientists calculated exactly how long this takes. The answer: at least 2 to 3 billion years of stellar recycling. The first generation of stars had almost nothing: pure hydrogen and helium, no metals, no rocky building blocks, nothing useful for making planets. Only after those first stars died could the second generation form, with heavier elements. Only after many generations could planets finally appear. But Methuselah formed after just 1 billion years. It arrived before the ingredients were ready. It formed before the cosmic recipe was complete. It existed before it should have been possible. Imagine walking into a restaurant and being served a gourmet meal before the kitchen was built, before the ingredients were delivered, before the chef was even hired. That's Methuselah. And nobody knows how it happened. If you've never heard of this planet before, drop a comment right now. Just write Methuselah. I want to see how many of you are discovering this mystery for the first time. So how did we even find this impossible world? The discovery starts with a dead star. Not just any dead star, a pulsar. When a massive star explodes, it leaves behind an incredibly dense core, a ball of neutrons packed so tightly that a single teaspoon would weigh billions of tons. This core spins incredibly fast and shoots beams of radiation into space like a lighthouse sweeping across a dark ocean. That's a pulsar. PSR B1620-26 is one such pulsar. It lives in a globular cluster called Messier 4. Globular clusters are special places. They're ancient collections of stars, some of the oldest objects in our entire galaxy. Think of them as cosmic time capsules, preserving stars that formed when the universe was young. The stars in Messier 4 are between 10 and 13 billion years old. Finding ancient objects there isn't surprising. But finding a planet there, that raised every eyebrow in astronomy. Here's how they found it. In 1993, astronomers were studying this pulsar's timing. Pulsars are nature's most perfect clocks. Their pulses arrive with incredible precision. You could set your watch to them for millions of years without losing a second. But PSR B1620-26's rhythm was off. The pulses were arriving slightly wrong. sometimes a tiny bit early, sometimes a tiny bit late. Something invisible was pulling on it gravitationally, disturbing its perfect timing. At first, they thought it was just the companion star. A white dwarf, another type of stellar remnant, orbits the pulsar in a gravitational dance. But the pattern was too complex. Something else was hiding in the system, something smaller, something they couldn't see directly but could detect through its gravitational influence. A planet. In 2003, the Hubble Space Telescope confirmed it. There's a gas giant orbiting this pulsar white dwarf pair, about 2.5 times the mass of Jupiter, massive, ancient, and according to our models, completely impossible. When scientists calculated its age based on the globular cluster it lives in, the number came back at 12.7 billion years. The astronomy community didn't celebrate, they worried. Because this wasn't just an interesting discovery, this was a direct challenge to everything we thought we understood about how worlds are born. So how do scientists explain this? There are three possible answers, and here's the uncomfortable truth. None of them are completely satisfying. Explanation 1: the planet was stolen. Maybe Methuselah didn't form in this ancient system at all. Globular clusters are crowded environments, hundreds of thousands of stars packed into a relatively small space. Stars pass close to each other frequently. Gravitational interactions happen constantly. Maybe Methuselah formed around a different star somewhere else in the cluster, a younger star with more heavy elements. Then, through gravitational chaos, it was ripped away from its parent and captured by the pulsar system. If this happened, the planet could actually be younger than its current home suggests. Its address is ancient, but its true age might be different. But here's the problem. Capturing a planet gravitationally is extraordinarily difficult. The speeds and angles have to align perfectly. It's like trying to catch a single grain of sand thrown from a passing airplane. The odds are almost zero. Simulations show that planet capture is extremely rare, possible in theory, but incredibly unlikely in practice. Most astronomers don't believe this explanation. Explanation 2: planets can skip the waiting period. Maybe we're wrong about how gas giants form. The standard model says you need a solid core first, about 10 Earth masses of rock and ice. This core then attracts hydrogen and helium gas through gravity, growing into a massive planet over millions of years. But there's another theory called disk instability. In this model, a massive disk of gas around a young star becomes gravitationally unstable. The gas clumps directly. It collapses into a gas giant without ever needing a rocky core. If disk instability works, you don't need as many heavy elements. You just need enough hydrogen and helium gas and the right conditions for the disk to fragment. The early universe had plenty of hydrogen and helium. If the disk around Methuselah's parent star was massive and unstable enough, a gas giant could form rapidly without waiting for heavy elements to accumulate. This is currently the most popular explanation among astronomers. But it has problems too. Simulations show disk instability only works under very specific conditions: high mass disks, cold temperatures, precise timing, and we're not certain those conditions existed commonly in the early universe. This theory fits, but not perfectly. Quick poll for the comments. Which sounds more likely to you so far? Stolen planet or skipped waiting period? Drop your answer. I'm genuinely curious what your instinct tells you. Explanation 3: our measurements are wrong. This one is uncomfortable because it questions our tools. What if our age measurements are off? We estimate the universe is 13.8 billion years old based on the cosmic microwave background, the afterglow of the Big Bang. We estimate the globular cluster's age based on how its oldest stars are evolving. Both methods have uncertainties. The numbers could be off by a few hundred million years in either direction. And there's another problem lurking in cosmology. The Hubble tension, our two best methods for measuring the universe's expansion rate, give different answers. If our cosmological model has flaws we haven't discovered, our entire cosmic timeline could shift. The universe might be slightly older than we think, or the cluster might be slightly younger. Maybe the gap between Methuselah's age and the universe's age isn't as extreme as it appears. But here's the reality. Even with generous error bars, even stretching every uncertainty to its limit, Methuselah remains absurdly ancient. The numbers compress slightly, but the mystery doesn't disappear. Something still doesn't add up. So which explanation is right? The honest answer, we don't know for certain. Most scientists lean toward disk instability, a gas giant forming quickly without needing heavy elements, but papers are still being published, debates are still happening, the case isn't closed. And that's what makes Methuselah so important. It's not just a strange old planet, it's a test for our entire understanding of how worlds come into existence. Now here's the part that genuinely haunts me. Methuselah isn't just old, it's a survivor. Think about what this planet has witnessed. It formed when the universe was still assembling itself, a chaotic era of colliding gas clouds and violent stellar births. It watched as galaxies slowly took shape over billions of years. It saw countless generations of stars live and die. Then its own parent star exploded. A supernova, one of the most violent events in the cosmos. A blast so powerful it would vaporize anything nearby. The shockwave should have destroyed the planet or flung it into the endless void. But Methuselah survived. Somehow it held on. Somehow it endured the apocalypse that killed its star. And it wasn't finished facing danger. The dead star became a pulsar, a spinning neutron star blasting radiation across space, one of the most hostile environments imaginable. Still, Methuselah endured. Today it orbits silently in that ancient globular cluster, 12,400 light-years from Earth, a silent witness to almost the entire history of the cosmos. When Methuselah formed, there was no Earth, no sun, no solar system. The atoms that make up your body right now were scattered across the universe, waiting billions of years to come together. This planet is older than almost everything you've ever known or seen or touched. And that raises a question that should keep you awake tonight. If Methuselah can exist, what else exists out there? If planets could form that early, maybe some of them were rocky, maybe some had liquid water, maybe some developed life. Life that had a 3 billion year head start on us. 3 billion years. Let that sink in. That's longer than the entire history of complex life on Earth, longer than fish, longer than dinosaurs, longer than mammals, longer than every creature that has ever walked, swam, or flown on our planet. What would a civilization look like after 3 billion extra years of development? We can't even imagine. Our minds aren't built to comprehend that scale of advancement. They could be so far beyond us that we wouldn't recognize them as life. They could be watching us right now. They could have seeded life across the galaxy before our sun even ignited. Or they could be long gone, extinct for billions of years, leaving only ancient ruins drifting through space, waiting to be discovered. Either possibility changes everything. And Methuselah is the reason we have to take them seriously. So the next time you look up at the night sky, remember this. There's a planet out there that broke the rules before anyone knew what the rules were. A world that formed before the ingredients existed. A survivor that watched the universe grow up around it. It's called Methuselah. And it's still waiting for someone to explain how it's possible. If one impossible planet exists, how many others are hiding in the ancient darkness between stars? Speaking of impossible things, scientists just detected a radio signal from deep space that repeats every 22 minutes. Nothing we know of should pulse that slowly. Not pulsars, not magnetars, not any known object in our cosmic catalog. I break it down in my next video, and honestly, it might be even stranger than Methuselah. Subscribe so you don't miss it. Drop a comment telling me which explanation you believe. Stolen planet, skipped formation, or measurement error. I read every single one. Thanks for watching. Keep looking up.